for deploy.
Understood. Drifting to the right level. Contact right. Eagle has landed.
Hey guys, Tori here from Overlook Horizon. Good evening to you, especially if you're here on the East Coast, where I am. We're here for another attempt at a Rocket Lab launch today, launching Rocket Lab's 15th mission. It is, what day are we on? Wednesday, October 28th, 2020, and it is currently 4:56 p.m. Eastern Daylight Time. So in case you're watching the replay, I'll make sure to put timestamps in the description below in case you want to skip ahead to all the good parts. But if you're here live, thanks for joining us, because we're in for an exciting launch today. Hopefully, we're in good shape. Actually, just a few minutes ago, Rocket Lab actually responded to my tweet to tell me that we're looking really good, because I was a bit concerned about weather going into this, but I tweeted at them a few minutes ago asking them how weather is, and they're saying it's looking pretty good. So that's fantastic. It looks like we're in good shape for an on-time liftoff and about 24 minutes from now. So we're counting it down. They did push it back about 7 minutes from with the opening of the window, but we still have plenty of time. They could even push back a little bit further. They still got another 40 minutes or so in the window in case they have to delay a little bit today. They could still do that, but let's not get ahead of ourselves. Let's hope for an actual on-time launch here, which is coming up at, what is that, 1721 UTC. Is that UTC? Is that right? Yeah, I think that's right. But anyways, Cooper on Facebook's telling me, hurry up, bro. I got no control over it. We're just here to watch. We're here to watch and have a good time and see what Rocket Lab is up to. So Rocket Lab, and I'll get to all your questions here, so make sure you drop them in the chat as well. We'll get to your questions and see what's happening, but I do want to at least get through some of this because Rocket Lab is going to go live. They'll chat it up a little bit. I'll augment a little bit of their live broadcast, and then we got a long time between launch and deployment. Deployment is about an hour after launch, so we've got a long period of time there where we'll watch some replays, answer your questions, and dive into it a little deeper at that point. So let's take a look at, oh yeah, there you go, Jaws Matt. Thank you for doing the math there. 21:21 UTC. 17:21 is the Eastern time. I'm getting all my times mixed up. But you're Jaws Matt over on Twitch. Thanks for correcting me. You are correct. It is 21:21 UTC, not 17:21 UTC. It'd be 17:21 EDT, my time zone. You're right. Anyways, Continuing on, let's pull up, so in case you're not familiar with what Rocket Lab is or what we have going on here today, Rocket Lab is a small satellite rocket company. They launched the Electron rocket. This is a much smaller rocket than, say, like the SpaceX Falcon 9 rocket. This is intended for microsatellites, for CubeSats, things like that, very small satellites, and that's kind of the market that they are going after. One of the really unique things that they have with this particular rocket is that they use an electric-powered fuel pump to pump the fuel into the combustion chamber, which is a bit unique. Actually, the first orbital rocket to use an electric fuel pump to get into orbit. Most of your other orbital rockets use a turbo pump, which is actually fed and powered by the actual onboard fuel. So it's kind of like a mini rocket engine inside the bigger rocket engine. That's what most of your rockets do, your orbital rockets do. This is the first orbital rocket to use an electric powered fuel pump to pump the fuels into the engine. And that can have kind of pluses and minuses to it. The plus side is you don't need as much hardened equipment for the actual pump mechanism, because you're not experiencing super high heating like you would on a turbo pump that's powered by the actual onboard fuel. The downside, though, is usually you have to take up a bit of your weight of your actual rocket with batteries that you now have to carry on board. So one thing Rocket Lab does that you'll see hopefully today during the launch is partway through their orbital insertion, they are actually going to jettison 2 of their batteries and do what's called a hot swap and actually get rid of some of those batteries so they can shed some of that unnecessary weight. So that's a very unique thing that Rocket Lab does, and they're also moving towards reusability with the Electron rocket. They're not quite there yet. This is launch number 15 they're going to start doing some reusability tests on launch number 17. So in 2 more launches from now, they're going to start doing reusability tests with a soft water landing initially. And then eventually the ultimate goal is to actually pluck it out of the air with a helicopter and then go set it down on a recovery ship and bring it back. And Rocket Lab has said that they're really only looking to reuse the first stage 1 time. If they can fly a first stage 2 times, you know, the initial one and then 1 reused one, they're like, great, fantastic, way to go. But it's all very relatively inexpensive, so it's not like the Falcon 9, which is launching a much larger rocket, or even some of the other rockets that are out there, much larger, much more expensive components and things like that. I mean, don't get me wrong, reusability here is still going to be beneficial for them cost-wise, but the reusability, they can still operate in profitable territory without the reusability. It's just going to be a little bit of an added bonus for them. So there you go. So, and this also has 3 stages on the Electron rocket. So you've got your 9 Rutherford sea level engines that are at the bottom here. You've got your Rutherford vacuum engine here that's on the 2nd stage. And then there's actually a kick stage up at the top, which is kind of a tiny little 3rd stage up top that'll do the final little, you get it into orbit. And obviously the satellites are wrapped in the payload fairing there up at the top. So what are we launching here today? This is launching a bunch of small satellites, most of which are for Planet Labs. So Planet Labs has a flock of satellites. They literally call them a flock. This is going to be part of Flock 4 here. They're launching these satellites. I suppose we could zoom in on this a little bit, make it a little bit bigger so you can see it better. But these are Earth imaging satellites. Take a look. Let me make sure get the Rocket Lab broadcast up because it looks like they're going live, but they haven't started yet. But these are Earth imaging satellites that are going to be in sun synchronous orbit, meaning they're going into a polar type orbit. It's going to look something like this. These are the existing Flock 4 satellites that are already up there in polar orbit like this. They're not quite exactly polar orbit, but more or less polar orbit going over the North and South Pole, as opposed to in east-west equatorial orbit. These are polar orbit, and they're going to be in sun synchronous orbit. And what that means is that they're going to pass over over a particular point in the sky. They will pass that point at the exact same time every day. And what that's really good for is Earth imaging satellites, especially if you want to do a comparison. You have the same lighting conditions to do a comparison from day to day, to week, to month over a particular area so that you can see how an area changes. They actually did this already with the Beirut blast here, which you can kind of see. I'll zoom in a little bit more as well. You can see where that devastating explosion was here in Beirut. You got the before, and then you got the after, and the satellite is able to pick that up very, very well because it passes over that same point at the same particular time. Also on board here, so in addition to the Planet Lab satellites, is actually a demonstration satellite for Canon. The Canon demonstration satellite is going to do some night imaging, as well as this part confuses me a little bit, and I'm not 100% sure what exactly the use case is for this, but there's a small-sized telescope on board as well. Love to see what they're going to use that for. I don't exactly know what they're using for, but it's a technology demonstration for Canon, kind of like a proof of concept. That's what they are going for. Hopefully Rocket Lab will give us some more info today when they go live. And we're already off to a better start here because Rocket Lab is actually going live. So we should hopefully get some sort of launch attempt today. Now, they did say, I did look at the weather earlier, like I said, this is the cloud conditions, so I was a bit concerned that it was cloudy, but what you don't get from this weather map is like how thick those clouds are. They can launch through clouds, just not super, super thick cumulus clouds. Usually we try to avoid those, but that was really the only concern. A little bit of a concern with wind speed. Ground level winds were looking pretty good, but upper level winds, we're getting up there. I don't know what Rocket Lab's limit is on upper level winds. I mean, it's only 49 miles per hour, which this would not be a concern for like SpaceX's Falcon 9, but would it be a concern for smaller rockets like Rocket Lab? I don't know. It doesn't sound like it. Sounds like this is still going to be okay for Rocket Lab, and they're going to push ahead. So now that they are live and chatting it up, I'm going to quiet down here for a little bit. We'll listen in on them, and then we're going to do kind of question and answers. I know people have been chatting. I might chime in if I see a particular question, but I will turn them up so we can listen in, and we'll do question and answer in between launch and deployment. So I'll be quiet now.
Today to prepare for this morning's scheduled liftoff at 10:21
I need more
a.m.
volume
New
than
Zealand
this.
time, or 9:21 p.m.
There we
UTC. Today's Electron mission is our fifth for the year, and it carries 10 Earth imaging small satellites bound for low Earth orbit. Inside Electron's fairing are 9 of the latest generation SuperDove satellites from Planet, the operator of the world's largest constellation of Earth imaging satellites. The 10th and final satellite on board belongs to Canon Electronics Inc. and was procured for this mission by satellite rideshare and mission management provider Spaceflight Inc. Canon's Earth imaging microsatellite sets out to demonstrate some of the latest technologies the company has developed for satellite manufacture, including a middle-sized telescope equipped with ultra-high sensitivity camera to take night images of the Earth, and a small-sized telescope which is suitable for CubeSat use.
Earth imaging satellites play a huge role in helping us monitor change on our planet. They provide actionable data on things like climate change, monitor and respond to wildfires, and they can help farmers to better manage their crops to deliver food to our tables. Now, for more about how we get our customers on board, let's go to Launch Complex 1, where we have Mission Integration Engineer Jane McNichol at Range Control. Jane?
Thanks, Dom. It's great to be with you today on this beautiful morning on New Zealand's East Coast. My name is Jane, and I'm a Mission Integration Engineer here at Rocket Lab. Each mission at Rocket Lab is assigned a dedicated mission manager or integration engineer, and we work closely with our customers to help them through the mission process, from the time they sign up for a launch with Electron to integrating their satellites onto the launch vehicle to successful deployment on orbit. Now, I'm standing here today at Range Control, which is about 3 kilometers away from the launch pad itself and the payload processing facility where the payloads for today's launch were integrated onto the launch vehicle. You can just make it out in the distance behind me. The payload processing facility is home to 2 state-of-the-art clean rooms where our customers can prepare their satellites for launch. But these clean rooms aren't the only ones that our customers can choose from. We have additional clean room facilities at our Long Beach, California headquarters for U.S. customers who want to integrate a little closer to home. And for customers launching out of Launch Complex 2 in Wallops, Virginia, we offer our brand new integration and control facility. Offering such a wide range of payload processing options is just one of the ways that we've created the most flexible and tailored launch service for small satellites. But back to today's launch, the team on console have been monitoring the health of the launch vehicle, including the payload environment in the fairing, as we progress through the count. All systems are currently green, and very soon Canon 2 and the 9-planet SuperDoves will be on their way to orbit. Back over to you in Mission Control.
Thanks, Jane. So, you're currently looking at a live view of Electron on the pad at Launch Complex 1. Electron stands 18 meters tall and weighs about 13 tons at the moment of liftoff. Electron itself is actually incredibly lightweight due to its black carbon composite structure. Almost the entirety of the rocket's first stage is filled with a mix of propellants for the Rutherford engines. Now, of that 13-ton liftoff mass, around 12 tons is actually the liquid oxygen and kerosene that fuels Electron on its way to orbit. The white stripes you see along Electron indicate where the liquid oxygen is being loaded inside the tanks. Because of the extremely cold temperatures of the oxidizers inside, any moisture on the outside of the rocket freezes in its place and causes those white stripes of ice to appear.
As we approach T-minus 12 minutes, let's check in with Mission Control for the final go, no-go poll.
Let's do it. Give it to us. You see Peter Beck, the CEO of Rocket Lab, is in the back row there. He's third from the left on your screen in the back row. Those
All right, to all stations, this is LDR mission. We are now proceeding with the go, no-go sequence. Stage, you go.
Stages go.
Avionics.
Avionics is go.
AFTS.
AFTS is go.
GNC.
GNC is go.
Beacon.
Beacon is go.
RF.
RF is go.
T1.
T1 is go.
GC.
GC is go.
BLS.
BLS is go.
RSO.
RSO is go.
MET.
MET is go.
MM.
MM go.
LD sub.
LD subs go.
And exec.
The exec is go for launch.
In all stations, go-no-go sequence is complete. We're currently T-minus 11 minutes, 20 seconds and counting. We're go for the terminal count start at T-minus 10 minutes. From this time, the three-way procedure is in effect.
All right, good news. Sounds like we're pushing ahead. You can see those clouds that we were talking about earlier. It is a bit cloudy, but so far it sounds like the weather is green. They did mention it a minute ago, but those white stripes, that's
Green
ice.
across the board. Electron is go for flight.
We can turn them down for just a second. Those white stripes are ice. That is not actually part of the rocket itself is completely black, but the white is ice, where you actually have that super cold liquid oxygen that is causing the condensation and ice to form on the outside of the rocket there.
Why don't you let us know a little bit about the Rutherford engines?
I'd love to. When Electron was first launched in 2017, these Rutherford engines were introduced as an entirely new type of rocket engine, due to how its propellants are pumped by an electric motor powered by batteries. Today, the Rutherford engine remains the first and only electric pump-fed rocket engine to fly to space, and with this mission, we'll have flown 150 Rutherford engines. The Rutherford is also the first oxygen hydrocarbon engine to use 3D printing for all its primary components, including the thrust chamber, injector pumps, and main propellant valves.
That's right. So for the second stage, Electron uses a single vacuum optimized version of this engine. And once it's in orbit, Electron's third stage, also known as the kick stage, takes over and carries out the final leg of the journey to deliver our customer satellites to precise custom orbits. Now, Electron is the only launch vehicle that delivers this dedicated, direct-to-custom orbit service for small satellites, even when flying on a rideshare mission. This provides a streamlined path to orbit for our customers and eliminates the added risk, complexity, and cost of having to develop your own spacecraft propulsion or using a third-party space tug to deliver your spacecraft to the desired orbit when flying as a rideshare.
Electron's kick stage, which also serves the foundation for our family of Photon satellites, employs our in-house design and manufacture.
There's a good view of the ice up top there on that second stage. Just wanted to jump in and point that out because it's really pretty clear there.
Across more than a dozen orbital missions. It's this unique and reliable propulsion system that ensures the kick stage provides our customers with unmatched flexibility for orbital deployment. It enables orbit raising, orbit phasing of multiple payloads on a single mission, deployment of multiple payloads to different planes and inclinations on the same mission, hosted payload support, and sustained low altitudes. It also enables deorbiting to avoid contributing to the growing issue of space debris.
This band is switched to high power for flight.
And just in case, I didn't mention this before, but just in case it wasn't clear, this is launching in New Zealand today. I did want to mention that because I failed to mention that earlier. So that is.
All engine blips are nominal, engines are ready, and stage terminal checks are complete.
Thank you, stage.
Stage 1 and Stage 2 high voltage batteries are ready for flight.
Copy avionics. GC, LD on mission, please proceed.
In around 8 minutes time from LC-1's Pad A, Electron will launch in a southerly direction along the east coast of New Zealand, making its way to sun-synchronous orbit and deploying the payloads at an altitude around 500 kilometers above Earth. At about 2.5 minutes after liftoff, the Rutherford engines on the first stage will shut down before the vacuum engine on Stage 2 ignites, continuing the satellites to orbit. At around 9 minutes after liftoff, that second stage engine will shut down and the kick stage will separate from the vehicle in preparation for payload deployment, about 60 minutes into the mission. Now, when the kick stage separates from Electron's second stage, it will be in an elliptical orbit around Earth. So after a coasting period, the kick stage's Curie engine will ignite to propel the payloads into a circular orbit around the planet, ready for deployment into their precise and individual orbits. Now, since we won't have live footage of that payload deployment, we'll be ending today's webcast shortly after kick stage separation, at around 10 minutes after liftoff. You can continue following our mission via our social media channels, where we will post confirmation of payload deployment.
All right, so I guess we're not going to see payload deployment today, so we won't have that big time between launch and deployments, but we'll stick around and answer some questions. I did see somebody asked, how do the batteries ignite? I believe the Rutherford engine is a spark plug ignition system, just like spark plug type ignition system, so it's not...
FTS is green and enabled for flight.
It's not
Cue avionics.
igniting from the from like a pre-burner that you would see on a regular turbopump engine. The batteries power the electric pump, which is pressurizing the fuel a little bit more and pushing them into the combustion chamber. So we're coming down on it. You can see some venting happening. It's completely normal at this point. Strong back is retracting there. You can see it pulling away.
Right now, we're at T-minus 6 minutes to launch. And a quick update on the weather. It's a little cloudy out there today, but we are currently go for launch. Our range control team at Launch Complex 1 has also given the all clear with the vehicle and systems healthy on the pad. Things are looking great for an on-time liftoff today at 10:21 this morning, New Zealand time.
We're excited to be on the pad, ready for another Electron launch. In the world of disruption caused by COVID-19 this year, we're proud to be continuing to serve the small satellite community with timely and affordable access to space. Assured access to space is something that governments and commercial satellite operators alike need to be able to rely on, no matter what disruptions the world might be facing. It's the very reason we developed the most resilient and responsive satellite launch systems ever created. Now let's take a look at how we made that possible.
To Launch Complex.
All right. I gotta turn this down a bit because they're playing some music, and I don't have the rights to play that. So we'll cover this for a couple minutes while we look at some of their nice scenery. Some people are confused. They're gonna show the launch, just not the deployment of the actual satellites. The deployment is scheduled for about an hour after launch. It sounds like they're not gonna show that. They're just gonna show us up until the kick stage separates, which is a few minutes after launch. I can't remember the exact timing. I have it here somewhere, but I think it's about 15 minutes or so after launch, and then they were going to end the broadcast at that point. So the deployment, they'll continue on. They'll just tell us about it about an hour after launch, probably on Twitter. Here's a good view right there. You can see how the Electron rocket is completely black. It's not that black and white pattern that you see now. That white is just ice that's forming on the outside of the rocket, which is launching here, Launch Complex 1 at the Mahia Peninsula in New Zealand. They have another launch complex that's getting ready to come up to speed at Wallops Island in Virginia. That's going to be Launch Complex 2, and they're going to be launching there very soon. But yeah, it's GM on Periscope says a very pretty launch site. It's probably one of the best launch site views out of any rocket company. This is Launch Complex 1 in New Zealand. It's amazing. This is amazing real estate right there. So there you go. Framrick checked me on the time. So 9 minutes is when they released the kick stage. Couldn't remember the exact time. I have it here in one of my things, but I'm trying to go through some questions here real quick. The coast period, yeah, about 40 minutes. The deployment's about an hour after launch. We will not see that. Do these rockets also land? They do not. There's no recovery right now. They're pushing forward towards reusability, but it'll be a parachute recovery, and then they'll scoop it up by helicopter. They're not there yet.
Wait to be hosting the webcast for simultaneous missions.
They're going to start trying those recovery options with flight number 17. This is flight 15, so they will, in 2 flights, they're going to start trying to do soft water landings first, and then they'll move on to the helicopter catch after they can successfully soft land in the water. How is the rocket so perfectly white? How is the ice so perfect? It's all
on mission. We go for auto sequence start at T-minus 2 minutes.
Here we go.
I can confirm at this time LD is launch.
Yeah, the white, you got super chilled liquid oxygen there, and it's just the water in the atmosphere that's touching that super cold surface, condensing and then freezing. So it turns you'll see all the white ice up and down the sides of it, where that super cold liquid oxygen is stored in the rocket. It's not. Are they like older rocket? This is a brand new rocket, so they just started flying this in 2017, I think was their first test flight. And so it's a very brand new rocket using a lot of new technology, but right now it's completely expendable. They're planning on reusability.
Green auto sequence.
We're not there yet.
Vehicles on internal power.
Mike says he's from New Jersey. Can usually see the launches. Not this one. This is in New Zealand. This particular one launching from New Zealand. So Rocket Lab is a U.S. company, but their primary launch site's in New Zealand.
Launch load is complete. Starting recirculation.
Secondary launch site is Wallops Island in Virginia. You might be able to see those, Mike. And again, the rocket is all black. Those white stripes that you're seeing, that's just ice frozen on the side of it from the water in the atmosphere just condensing and freezing. Got some pretty cool sounds that you can hear. Make sure I got my volume all the way up. Rocket Lab, one of the really cool things when the engine ignites, it's so powerful. It's like, ooh!
Stage 1 tanks are pressed.
So watch that when that happens.
And stage 2 tanks are pressed as well.
High flow engine purge is enabled.
I'll get my stuff out of the way here in a minute. Is it that cold? Yeah, liquid oxygen is like negative 340 degrees Fahrenheit.
Gauge is activated.
Very cold. Flight path is to the south. It's polar orbit.
T-minus 20 seconds and counting.
Here we go. Listen for that ignition. It's pretty awesome. I'll put this up here so we can keep an eye on that.
5, 4, 3, 2, 1.
Stage 1 propulsion is nominal.
Oh, that sound! Oh, love that!
HVB battery discharge nominal.
And there goes Electron for our 15th launch from Rocket Lab Launch Complex 1 in New Zealand. We're T plus 50 seconds and Electron is approaching max Q, or maximum aerodynamic pressure, the moment during its ascent when the forces against the vehicle are at their strongest.
Cleared maximum dynamic pressure.
God, that sound is nuts. So there's max Q. And you can I love how they keep the pad microphones going. You can still hear it.
Enter Chevron 3.
Not anymore. So the next event that we're coming up on is going to be MECO. At about 2 minutes and 31 seconds into the flight, you can see the exhaust plume from the rocket there starts to expand outwards as it gets into the less dense atmosphere there. Always love that. You can see some of the ice kind of falling away too. Did they ever fail a mission? Yeah, Rocket Lab.
Next up will be 3 events in quick succession. We should hear the call for MECO as Electron's Rutherford engines throttle down to allow for stage separation before the engine on the second stage fires up to continue the mission to orbit.
Entered stage 1 burnout detect mode.
So we're coming up on that MECO. And we'll get separation here in a bit. Camera's kind of cutting in and out a little bit. When it's not cloudy, this is an amazing view here, but we're just seeing all clouds today. So we should get MECO any second here. It was scheduled at 2:31, but I can adjust in flight. There we go.
Separation confirmed.
Stage 2 ignition confirmed.
We're gonna watch. We'll have to watch that again too. It was pretty cool looking.
Successful MECO confirmed by Mission Control. Propulsion is continuing nominally on Electron's second stage at T plus 3 minutes into the mission, with the vehicle now travelling at several thousand kilometres an hour. Soon, the fairing halves will separate and you'll be able to watch them fall away on your screen there.
There you go, there's one fairing
And
half.
there they go. Electron has successfully jettisoned the fairing and is continuing nominally towards orbit.
You see both halves of the fairing right there. That's pretty cool.
Stage
So that battery hot swap that I was talking about, that's going to come up in a couple of minutes here. That's kind of the next big event, will be battery hot swap. We still got a couple minutes before we get to that, but that's when they will jettison 2 of the 3 batteries so that they can get rid of that extra weight that they don't need. Somebody asked if they have ever failed.
For those of you just joining us for today's launch for Canon and Planet, we've made it through liftoff, main engine cutoff, stage separation, and stage 2 ignition. Electron is traveling through space at 9,000 kilometers per hour and is currently at an altitude of 153 kilometers.
So like I said, I started saying, somebody asked about failure. They've had a couple of failures, but it's still a very new rocket company. They had a failure. It was actually for Planet Labs. One of their flocks, like this one, failed on flight 13. But
while we're
that should be
coasting
resolved
through
now.
the vacuum of space, let's delve a bit deeper into Rocket Lab's engines. Each of the Stage 1 Rutherford engines weighs around 35 kilos or 77 pounds and comes in at around 800 millimeters or just under 3 feet. A Stage 1 engine is capable of 24,000 newtons of thrust. Stage 2 is the same base engine with an extended nozzle. This vacuum nozzle increases the size of the engine 2-fold and adds an additional 1,000 newtons of thrust.
So we're looking good so far here. We're waiting on that battery hot swap. Again, this is very different from SpaceX. Right before battery hot swap is where they had a problem before on flight 13. But it looks like we're already
Another quick check-in from
past
Mission
that point.
Control. We're T plus 5 minutes into the flight, and the Electron is continuing nominally through its second stage burn.
Somebody asked what happens if a launch fails. Do they refund them? So all the payload providers would have insurance. They purchase insurance to make sure that their investment is protected before they
Electron's
launch.
next action will be to swap out the onboard batteries for a fresh new one in what's called a battery hot swap. Let's listen in for the call of that swap.
HBV battery discharge nominal, approaching hot swap in roughly 30 seconds.
A battery hot swap coming up right around 6:30-ish.
Throttling down.
You might even see the batteries jettison.
Hot swap successful.
There you go.
Battery ejection confirmed.
See it right there.
AFTS is safe.
And we've had a successful battery hot swap. Electron's second stage engine continues to propel the payloads towards their targeted orbit.
So the next big event here is going to be SECO. That'll be the cutoff for the second stage. That's coming up just under 9 minutes. Then there's actually a third stage.
Propulsion still holding nominal.
There will be a third stage, which is the kick stage. It will separate.
HBB battery discharge holding nominal.
So we're in great shape, well past where they had problems on flight 13. So this is looking good for Rocket Lab here.
We're at T plus 7 minutes since liftoff. In the next minute and a half or so, Electron's second stage Rutherford engine will power down before shutting off. We call this SECO, which stands for second engine cutoff, and this allows for a clean separation of the kick stage. Then, the kick stage will light its Curie engine and continue on its trajectory, coasting for a time before relighting its engine to carry the satellites closer to their optimal position orbiting Earth. We'll be ending the broadcast shortly after we hear confirmation of successful SECO and stage separation.
So not a lot of time left, but we will do a replay in case you missed the actual launch, because I love that sound. We got to replay that launch sound for sure. So we're coming up. We're under a minute to SECO.
Okay, entered stage 2 burnout detect mode.
This is burnout detect. So basically, once the engine burns out, that's when they initiate the separation sequence.
Guidance is in terminal, 20 seconds remaining.
So somebody asked, Fabrizio wanted to know why is the altitude decreasing. So hold on, we'll tell you that in a minute.
You can see the engine on stage 2 has shut
Separation
down.
confirmed.
We're now waiting for
Maxwell
kick
orbit
stage
is nominal.
separation. We've just had confirmation that the kick stage has separated. With another 40 minutes or so until that final cured engine relights, we're going to end the launch broadcast here ahead of payload deployment. We'll share the news of mission success on our Rocket Lab social media channels within the next hour.
Thank you to our small-sat customers, Planet and Canon Electronics, for choosing to launch on Electron today. I'm Ariana Ryan.
I'm Dominic Vu. This is Rocket Lab Mission Control, signing off.
All right, well, that's going to do it for Rocket Lab, but we're still going to chat it up a bit. We ought to, we're going to have to go back and replay that a little bit. But, yeah, that was pretty good. We had a nice... Oh, wow, they ended that really quickly. I'm going to have to refresh my broadcast there. Yeah, so launch was successful. I think I missed it when during the broadcast what they said exactly, but I think they said that they weren't going to show the payload deployment because they were going to be out of video range. They weren't going to have a video feed for it, so they were like, well, there's no point in staying live. We'll just let you know on the Twitter machine. I believe that's what they said, but I didn't exactly catch it. They said it early on in the broadcast, but I missed it while I was trying to mess with everything up here. So I'll get to some of your questions here, and we'll do a replay, and we'll check that out. What are they hiding? Yeah, they're not really hiding anything. I mean, again, a lot of people get this confused. I feel like I say this over and over again, but these camera views, although entertaining, their primary purpose is not to entertain us. They're a rocket company. Their primary purpose is to launch their customer's payload, and they really have no obligation to show this at all to us. They just like to do it. So, yeah, so they're not really hiding anything. I mean, there are areas on the globe where it's difficult to get video coverage, and I believe that they said this time around that they just wouldn't have video coverage. Sometimes the customer requests not to show it. Sometimes they're like, hey, our stuff's proprietary. We don't want you showing what our satellite looks like. So sometimes they do that as well. All right, let's get back to the launch and let's do a replay. I think. Oh, you know what we should test out? I forgot about this. Let me see, does this work? If I do this? Yeah, there we go. I forgot I created that. Meant to test that out earlier today. Okay, anyways, this is me just geeking out over weird little things about the broadcast here today. All right, let's go. We'll get it up here. We'll keep the sound down for a minute here. We'll get to the last couple minutes of launch. Actually, what I'll do is I'll go to their promo video that they showed so we can see all those nice views. And I'm going to go through and see if I can grab some questions here. Steve Robinson, awesome 2-Minute Tuesday. Thanks, Steve. Thanks for watching 2-Minute Tuesday this week. I was working on next week's 2-Minute Tuesday a little bit right before broadcast. I'll be doing more of that tonight. Crew 1 launch, 5-hour feed from SuperDove. Yep, that's the plan. It'll probably be about a 5-hour long live stream, or it'll start 5 hours before launch. That's the plan for Crew 1 coming up on November 14th. Be the next crewed mission. Let's see. Oh, Fabrizio said, remember my question. He asked about why the altitude is going down. So they don't always go up for rockets. Once they get to about their target altitude, sometimes they actually pitch down to circularize their orbit a little bit. It's really difficult to explain, but as they launch, sometimes they'll launch and they'll go up, and then once they get to their rough altitude, sometimes they may be traveling this way but thrusting this way. And so they're traveling like this, but by thrusting downwards, it helps circularize their orbit on the other side of the planet. So sometimes you'll see the altitude. It's not quite that drastic, but sometimes you'll see the altitude tick down just a little bit, and that's just orbital mechanics. They're trying to get that nice circular orbit, or at least that's the target. Let's see. Let me go back and grab a couple of questions. Might have been the best sounding rocket. It is a pretty awesome sound. I love the sound of Rocket Lab ignitions. A couple of people asked what was being launched. These are Earth observation satellites, so they're going to take pictures. There's one Canon satellite that's a technology demonstration from Canon that's doing night imagery. It also has a small telescope on board, and the other ones are from Planet Labs taking Earth observation images as well. All of it in sun-synchronous orbit, meaning it goes over the same spot, a particular point on the planet at the same day, or same time each day. That's what sun-synchronous means there. So let's see, we're about 3 minutes away from the replay on the launch. I should probably put up the replay text. Huh? It's hidden. We'll put it here. Where should I put it? Put it here? Put it there. I guess we'll put it there. We'll put it there for now. Get the replay text up there, so people don't get confused. Sound was amazing. Yeah, we're definitely going to watch it. We'll have that sound here in about 2 minutes, as I'm just using this time to go through some questions. So I think having a full broadcast could cost more for the customer, which is why some opt out. Now, I don't think it really has anything to do with the cost. I mean, I think it's really just logistics. If they have a video feed and the customer has no objection to showing all the way up to deployment, then they can go for it. Remember, Rocket Lab is a relatively small company. I mean, they don't have unlimited resources for tracking stations and video feeds that cover the entire globe. So, some of it is just the limits of what they're willing to pay for and implement for our entertainment. And also, I should clarify that those video feeds are generally not for entertainment. They're engineering video feeds so that their engineers can see what's happening, which is great to have for them, but they don't always need it for a successful mission. Let's see. Going back through a couple more comments. We're a minute and a half away from launch. I'll turn up the volume here in just a minute. Let's see. Oh, what video editor do I use? I use Adobe Premiere for my videos. So what is this launch? So this is launch 15. It's called In Focus, and they were launching a bunch of small satellites, 10 of them, for Earth observation and Earth imagery. So we're coming up again. We're about 50.
Stage 1 tanks are pressed.
50 seconds from a replay
and
here.
Stage 2 tanks are pressed as well.
What's this for? This is Rocket Lab. Small rocket company. They launch small satellites, but they're a brand new kind of up-and-coming rocket company doing very exciting stuff with newer technology that's a little off the beaten path, unusual. It's something that's new. Electric-driven fuel pumps. That's new. First orbital rocket to ever use electric fuel pumps. There have been the Agena rocket used an electric pump on its upper stage, the second stage, but the Electron is the first to use it to get to orbit on the first stage. Let's put this one up. I don't have replay text.
5, 4, 3, 2.
Hold on. Pause just when you thought it was going to get exciting. Hold on. I want to make sure to get this replay text up, and I don't want to miss the sound itself, so I'll back it up. Everybody was like, 3, 2, ah! We'll back it up. We're going to play it. Hold on. I just didn't want to miss it myself. This is your headphone warning as well, in case you missed the actual launch. It's very loud. It's very loud. So let's have fun with that. Okay. Ready? Here we go.
5, 4, 3, 2, 1.
Stage 1 propulsion is nominal.
I told you it was loud. I love that sound. We're gonna watch it again. We're gonna watch it again. All right, hold on. We're gonna do that again because I mentioned this live, but in case you weren't here watching live, the actual, like the fury, the power behind that ignition, it's very like when it finally ignites. We'll watch that again here. It's loud. If you don't want your ears to bleed, turn your volume down. Take your headphones out. I'm leaving them in though because I love it. This is as loud as I can get it. FYI.
5, 4, 3, 2, 1.
Stage 1 propulsion is nominal.
That's awesome. I could watch that 100 times. I love that ignition. That
HVB battery discharge nominal.
Is that not awesome? I love
And
that
there
sound.
goes Electron.
I love that sound. It's amazing. We should probably watch it again, but we'll keep this playing here for just a second. Hey, GVA Morning Show. Thanks for the super chat. Appreciate the support there for the channel. New road closures for Starship SN8 testing. 2 primary dates, November 1 and November 2. I saw that. That's pretty exciting. SN8 for SpaceX is going to be the vehicle that hopefully does that 15-kilometer or 50,000-foot test flight. Hopefully in the next couple weeks. I think the November 1 and November 2 was going to be cryogenic testing. So we're not quite there yet, but it's one step closer to a test flight. So that's pretty awesome. Let's see. Somebody wanted a scale for the rocket. I don't know if I have that readily available. Let me see. See if I can find a size comparison. What happened to my music? Let's see. Do I have a size comparison? If somebody has a size comparison, somebody should send it to me or tweet it to me. Tweet it at Overlook Horizon here, if you have one, because I don't know if I can find one on the spot. That might be too difficult for me to broadcast and find it at the same time. So tweet it at me if you have a size comparison so I can show it on screen for the Electron versus like SpaceX or something like that. I don't have one prepared. Get the 3D rocket out. Yeah, I only have a 3D print. That's a great idea. I only have a 3D print for a Falcon 9. Why do I not have an Electron 3D printed? I'm doing that. I'm going to 3D print an Electron. We're doing that after this today. Great idea. Your idea. 72 Galaxy Tank Girl. Appreciate it. What's the buildup on the left? I think you're talking about just ice. So right here, this is that ice, that white striping that we were seeing on the outside of the rocket here. Back it up. So this rocket is not black and white. It's black. This is a all black rocket, but the white that you're seeing is all just a relatively thick sheet of ice. Let me see if I can go back. They showed it pretty close up on the second stage right here. If you look right here, you can see You can kind of see the texturing here, but this is all just a sheet of ice here, and that's where the super cold liquid oxygen in it is. That's like negative 340 degrees Fahrenheit that liquid oxygen tank is. So crazy cold. And the water in the atmosphere and the air, when it touches that super cold surface there, it condenses and then freezes, and you just get a sheet of ice. Same thing actually happens on the Falcon 9 rocket as well. It's not nearly as obvious because the Falcon 9 is not this solid black color there. So that's just ice. Jaws Matt said you sent it to me in Discord. In Discord. Let me see. I gotta open up Discord because I don't normally have it open when we're streaming. Let me see. Jaws Matt said he. Somebody's sending me screenshots of myself in Discord. If you're not a member of our Discord, it's free. You should jump in. I'm sure one of the moderators will drop a Discord link in our YouTube chat. And you should join to chat it up with like-minded space people like myself. Let's see. I can't find it, Jaws Matt. I don't know where it is. You got to tell me what channel it's in because I can't. Is it share special? No, I don't see it there. I don't see it in Hangout, but there's a million chats in Hangout that I missed, so I'm just scrolling fast. I don't know. I don't see it. Okay. Let's go back and I should also drop in case you're watching on Facebook or on Periscope or on Twitch. I'll drop a Discord link in there in case you're not already a member. And then I'll take this point. We're going to do another replay here. Actually, I want to fast forward to the stage separation because that was kind of cool looking as well. But I'll take this moment to say if you want to help support the channel and you like this kind of stuff and you like hanging out, consider becoming a Patreon member or a member of the YouTube channel. And you can get behind the scenes access, some special exclusive live streams that only our members get. And you also get access to our super top secret Discord channels, which our existing Patreon members always tell me that they're not super top secret if I keep telling everybody about them. But there you go. You can become a channel member, help support the channel, and get you a little bit of bonus content. And then you have that good feeling of being part of my inner circle and being a main contributor to the channel. You also get early access to 2-Minute Tuesday videos. They come out for you on Monday instead of Tuesday. So it's 2-Minute Monday for Patreon members. Okay, let's get in your Hangout channel, says Jaws Matt. I don't see it, Jaws Matt. Oh, there it is. I see it. I see it. Thank you. Let me open it. This is great. Thank you, Jaws Matt. So Jaws Matt sent me in Discord a size comparison. Let me go over here so you can get an idea on what we're talking about size-wise here. So here's the Electron rocket, this little tiny rocket over here. Here's our Falcon 9, much bigger, much bigger. Here's a person for scale, right in here. Person for scale, person for scale. So Electron rocket, little tiny rocket, but it launches small satellites. That's the idea. Small, compact, economical. There, that's it right there. It's only 16 meters. Is that what that says? 16 meters in height versus the 70 meters of the Falcon 9. Can launch 150 kilograms to low Earth orbit versus the Falcon 9, which launches 22,800 kilograms to low Earth orbit. Size comparison there. Big difference. Big difference. Thanks, Jaws Matt, for searching that out for me and providing it so that I didn't have to. Okay. Mr. YouTube sent me an actual photo on the Twitter machine. He must have tweeted one to me. He did the tweeting. Where did you send? Leo sent me. Oh, there you go. Here here we go. I like these. These are great too. Here's one from our Jerry. Jerry's one of our Patreon members. Thanks for sending that over. Let's see, can I zoom in on this? I can't zoom in on that. Why can't I zoom in on that? Open image and new. Yep. All right, here you go. There's the. Oh, it's a little bit pixelated. Let me see. Hold on. Somebody. Leo sent me one too. See if that one's any better quality. That one's a little bit bigger, I think. Just a touch bigger. There you go. Human for scale. So you can see Peter Beck standing next to the Electron rocket. A little bit smaller. So you can see the size there. There we go. All right, let's get back to watching the replay here again. I wanted to show, I'm gonna go over here and get out of the way, because I want to show the separation event, which is kind of cool looking. Right here. You can see when that engine ignites.
Separation confirmed.
Then it just yeets out of
Stage 2
there.
ignition confirmed.
Leaves the second stage behind. And it's interesting to see because we're used to seeing...
Separation confirmed.
A lot of us are used to seeing the SpaceX second stage.
Separation confirmed.
Being a little more controlled.
Stage 2 ignition confirmed.
After separation. And this one, not so much. I mean, it's just gonna... At least right now, this is just gonna be expended in the atmosphere here. But soon, they will bring that back a little more gracefully. So there we go. So that was the other bit that I wanted to make sure was that we saw. But let's watch. Let's go back to the actual launch itself, because that sound is just amazing. We get to a couple other questions. A couple people asking about Discord. Yeah, Discord is free. No, nothing required. You can join Discord just to chat it up, learn more about rockets in between. Join our community. Become part of the Space Lobster Nation over on Discord. Or even if you're just here and subscribe to the channel and watching and things like that, that's cool too. If you don't have to spend money and be a Patreon member and all that kind of stuff just to be a contributor. Just chatting and things like that. Those are awesome contributions. Framrick says, by top secret, I mean announced on YouTube. Yeah, sorry, top secret Discord channels. By top secret, I mean not so secret. All right, we're about 25 seconds away. I'm going to turn this up again. It's super loud. Don't blow out your eardrums, but I'm going to crank it as loud as I can make it because it's awesome.
In 5, 4, 3, 2, 1.
Stage 1 propulsion is nominal.
That sound, I'm telling you, every time, I love it. So I want to answer Zavaz's question.
Battery discharge nominal.
Zavaz has a really good question, which is it's a very commonly confused topic in spaceflight, especially because we launch our own weather balloon flights, and a lot of people ask us about our weather balloons. So Zavaz's question is why, when it goes up, it does not burn up in the atmosphere, but when it falls, it burns up in the atmosphere. The whole burning up in the atmosphere is due to speed. So the reason why spacecraft or rocket engines or things like that burn up in the atmosphere as they come back is because they're going so fast that the air can't get out of the way fast enough. So you get all that air is building up in front of the rocket, which causes heating from all that big pressure, that big buildup of air, causes atmospheric heating. So simply going from out of, like, our people ask us about our weather balloons because we get down to like 1 or 2% atmosphere with our weather balloons, and they're like, oh, this would burn up on re-entry. It's not traveling that fast. Like, our weather balloons come back down. They do go pretty quick. They can go 150 or 200 miles per hour coming straight down, but that's not nearly fast enough for atmospheric heating. Same thing on the ascent. It's increasing its speed, and actually if you increase your speed too fast, you can run into atmospheric heating on the way up, but they specifically don't go too fast so that they don't run into that. And so generally they will, when you launch a rocket, you go up over the atmosphere and then kind of, and then turn so that you can really accelerate at that point. So it's the speed that's the problem, not necessarily the atmosphere itself. The atmosphere is fine. It's just the speed is the problem. A couple people asked what Discord is. Discord is just kind of like a chat server where you can chat, talk to people, talk about space, ask questions, learn about stuff. It's kind of like the old school chat rooms. It's just a chat room that's specifically full of a whole bunch of space geeks like me. How do I find it? You got to use the special invite link. So Marcus on Facebook was asking that question. How do you find it? Go up in the Facebook comments. Actually, here, I'll just drop another one for you. You got to use that special invite link. Can't get access unless you use the invite link. Any news on the parachute helicopter? So they're going to start testing the first stage recovery with Flight 17. This was Flight 15. So they will start doing... They'll start doing recovery tests by soft landing in the water first with Flight 17, so in 2 flights. And then they'll move on. Once those are successful, they'll move on. There's our fairing deployment right there. You can see the fairings going away. But they'll move on to the helicopter catch after they can successfully soft land in the water first. Are they using fairings? They do use fairings. That's what just jettisoned. They don't reuse the fairings. They don't recover those. Those are expendable. Again, very small rocket. They are using fairings. They just don't recover them. It's going to be tricky trying to catch it by helicopter. It is. It's kind of a crazy concept. Let me see if I can find it real quick to show you what that's going to look like. I don't know if I have... Let's see, I can pull it up here real quick. Let me show you quickly what that's gonna look like, if I can find it. Here it is. So I can show you what their plans are. We'll get rid of this replay here. Their plans are for reusability. So we're not there yet, but starting with Flight 17, they're going to try to soft land in the water here. So the idea is they're going to launch the rocket. They'll have this helicopter and this support ship that's out in the water here off the coast of New Zealand or Virginia, wherever they're launching from. After separation here, that first stage will then do a somewhat controlled re-entry here. It's not quite the same re-entry that like the Falcon 9 uses. So they're not doing things like, I don't believe they're doing an entry burn at all. They're just plowing right back through, just dropping like a stone, trying to come back through. And they've talked about, I don't know if they're still using this, but in the early plans, they were planning to use a ballute, which is what you'll see deploy right now, is going to be the ballute, which is basically like a combination of a balloon and a parachute together. That slows them down. Then they've got a kind of this steerable parafoil. Actually, I don't know if it's steerable, but they have this parachute here, and then the helicopter will grab this kind of drag line right there and scoop it up, which collapses the parachute, and then they bring it back. They're good to go. Now it's going to be a couple of flights before they get to this point. So they're starting with just soft landing it in the water, no helicopter. They're going to start with just soft landing it in the water and see if they can get that far. So that's where they're going to start. All right. Well, that was pretty, I don't see anything that could go wrong. There's a few things that could go wrong there. All right. Well, I think basically at this point, we should probably wrap it up here now because they're done. We got a successful, at least initial orbit insertion. They still have that kick stage that they have to go, but they're not going to ignite that kick stage until, actually they should be coming up on ignition in about 10 minutes, but they ended the broadcast, so we won't see that. And then deployment is still another 20 minutes from now, so they will we'll have to wait until they mention it on Twitter. But if you're a Discord member and you're in our Discord, you'll see it in the Team Space channel because it automatically posts when Rocket Lab posts. So there, another reason why you should join our Discord. All right, everybody. Well, thanks for joining us for another exciting launch here today. This was nice. Hopefully we'll have a couple more coming up here soon. If you haven't watched 2 Minute Tuesday, make sure you go watch 2 Minute Tuesday from yesterday about the Buran Space Shuttle lookalike. Space Shuttle 2.0, maybe? Space Shuttle copycat? I don't know. You tell me. Tell me in the comments. Go watch 2 Minute Tuesday from yesterday. And if you've already seen that one, then get ready for 2 Minute Tuesday next week. All right, that's going to do it for me, everybody. My name's Tori. This is Overlook Horizon, and I'll see you next time. Hopefully, maybe I'll see you in Discord to chat it up some more. Thanks, everybody. Have a good rest of the day. Goodbye.